terms, starting with the first term, ending with the eighth term. Now, like I said last time, you're not going to have to do this for every single problem, but I think it helps at the beginning. If you're adding 8 terms, and it's only 8 terms, why not list all the 8 terms? So this is kind of like what we did on the quiz. What's the first term using this formula? First term is 4. And you probably have it written down, so keep telling me. Do you have these terms written down? No? Oh. All right, well, what would the second term be? It's got to be 8, right? Because we're multiplying by 2 every time. The next term would be 16, and then 32, 64, 128. Whoa, these numbers got too big for you, huh? There we go, 256. And 512. How do we know that's it? That's the 8th term. And we're only adding from the first term to the 8th term. So this is not a huge list of numbers here. You could probably just type all this into your calculator and hit enter and be done with it, and it wouldn't be that big of a deal. But could you imagine how stupid this problem would be if it was from 1 to 81? You understand what I'm saying? You could, if you really wanted to, list all 81 terms and add them up. But that would be a really dumb way of doing the problem. Okay? Last time on Tuesday we learned about this formula right here. This is the finite series. What does the word finite mean?
Limited.
It's limited. It starts and it stops. That's what finite means. Doesn't this series here start and then stop? So if it's a finite geometric series, rather than adding these numbers up one at a time in your calculator, you can use the formula. The sum is equal to the first term over 1 minus r times 1 minus r to the n. That's a formula that you are going to want to have memorized. Because if you want to use this on the test, and I'm pretty sure you're going to want to use this, it's going to have to be from memory. I'm not going to give you this formula. Okay? What's the first term? Okay, and then 1 minus r. R is the common ratio, so the common ratio is 2. 1 minus 2 is negative 1. And then it becomes 1 minus 2. And then n represents how many numbers you're adding up. You're adding 8 numbers, so it's... That means you start at the first term, and this is the first term, and you end at the 8th term, and this is the 8th term. Yeah. So let's just calculate a problem. So if you type in negative 4, and then in parentheses type in 1 minus 2 to the 8th power, you get 1020. And that's the same number you would have gotten had you had you added all these numbers up one at a time in your calculator. The sum is 1020. Bless you. So here's one I want you guys to try on your own, right there. Evaluate that summation from 1 to 12. Negative 2 times 3 to the n minus 1.
Sure be nice if you had paper out taking notes. That'd sure be nice. Rather than just taking a 90-minute break. Not what you're here for.
You want to take a 90-minute break, stay home. If you're in school, then be in school. And you forget that you have to do what I tell you. So if I tell you to take notes, then do it. No. Short, yes. He's got short hair. A little bit older. No, he's a little bit older. I don't know. I didn't challenge him to a fight yet. That's how they should decide who the principal is. They get all the teachers together and say, last man standing. It'd probably be the teacher that went and hid underneath the bleachers until everyone was dead, and then they came out and said, "Hey, I'm the winner." Yeah.
Yeah.
I'll just go hide in the ceiling. The answer should be negative, because each term of the sequence is negative. If you start at -2 and then multiply by 3, you get -2, -6, -18. So you're adding up a bunch of negative numbers. Now, I only had you list all the numbers on this problem up here. You don't have to list all the numbers in the series. You just have to use the formula. Okay, you guys check it out. Can you use this formula to add up just any random numbers that you want?
Yeah.
This formula can add up any list of random numbers. What did I tell you this formula was for? Finite sum of what kind of series? It's got to be geometric. How do we know this series is even geometric? How do we know we can even use this formula for that problem? Does it have a common ratio? Then it's geometric. What is the common ratio? 3. Okay, so the point I'm trying to make is this is only one formula to add up numbers, and it only works for a geometric series. Okay, there's other types of series. But at any rate, what's the first term? And then you've got 1 minus 3, and then 1 minus 3 to what power? 12th power? Well, the programs? Just bring it in. Yep. So, -2 divided by -2, that's just 1. So really I got to type in is 1 minus 3 to the 12th power. It's going to be -531,440. Okay. Next problem, I'm going to ask you to go backwards. I need you to listen carefully to the directions before you try this problem. I'm going to give you a geometric series starting at a number and ending at a number. I don't want you to add up all the numbers. I don't care what the total is. I want you to take that series and represent it using a sigma notation. You got me? So what things do you need to know in order to make a sigma notation? The first term. You need to know what the common ratio is. You need to know how many terms are adding up. Right? So that's what I'm asking you to do on this problem here. Don't tell me the sum. I want you to try to represent it using a sigma symbol. 27 plus 9 plus 3 plus 1 plus 1/3 plus 1/9. What would that look like if it was in sigma notation? Yep. You need to know how many terms you're adding together. You need to know the first term. You need to know the common ratio. All of those things are very easy to find just by looking at it. How many terms are we adding up? 6. So on the bottom of the sigma, you should have n equals 1, and then at the top you should have 6. Assuming this is the first term of the sequence, and you can start at 1. Yeah. So if we're adding 6 terms, you start from 1 to 6. The only other thing you need is the explicit formula, but we just practiced that about 4 times on the quiz. To make the explicit formula, you need the first term and the common ratio. First term, obviously, is 27. The common ratio is less obvious, but it's still pretty easy to find. What's the common ratio? 1/3. So it should look like this. Okay. The summation from 1 to 6 of 27 times 1/3 to the n minus 1. Now, an equals is a way to find just any random term. This is a way to add up terms of a sequence. So they're different.
What if I got that equation without adding it?
You got this.
Yeah.
Okay, but that's only part of what you need, because 27 plus 9 plus 3 plus 1 is different than 27 comma 9 comma 3. All this does is list what the numbers are. This tells you you're adding them together. This symbol right here. And that's what you're doing, is adding these all up, right?
Okay, so you put the root terms on the top.
Yep. And the symbol means that you're adding up all those terms, and that's what you're doing here, is adding up all those terms. And this expression tells you what those terms are going to be. Because that's the first term you're starting with. Yep. Get your calculators out, your TI-84s if you have one. I don't know if I showed you this last time. If you have TI-84 plus, it'll work. I don't think it'll work on an 83. It's worth looking at it, but I think it only works on an 84. Okay, you see the green alpha button. Hit the green alpha button. Now go up to the top row and hit window. Do you see a symbol in there that might be something that we're talking about? So go to option 2. Would you look at that? Oh, did I? Oh, yeah. I remember that. So anyway, let's do this problem right here. We're going to start with n equals 1. So if there's a capital A, do you see how there's a capital A on your cursor? That means you can type in letters. So I'm going to actually use the letter N instead of the letter X. So go down to the log button. Do you see right above the log button there's an N? So hit that. As long as there's a capital A on your cursor, it'll type the letter and not the log button. So N equals what? This problem right here. 1. Now cursor over. Then it brings you to the top of the sigma. We're going to go to 6. Now cursor over. Now you can type in the explicit formula. 27 parentheses 1/3. And now you raise it to a power. Now remember, I need you guys to stop for a second. Whatever letter you use right here at the bottom of sigma, that's the same letter that you have to use here in your formula. So you can't mix variables. If we use an n here, you've got to use an n here. So hit the alpha button and then hit log. That'll give you another n. And then minus 1. Yeah. What does this number even mean? 40.44444. What does that mean? What's that? That's all of these numbers added up, you guys. What I'm getting at is this. You know how we had to use this formula right here? A sub 1 over 1 minus r times 1 minus r to the n. That formula works, but couldn't we also have used this feature on the calculator to find the same thing? Go back to this problem here that we already know the sum. The problem we started with, 4 times 2 to the n minus 1. If you do another summation, starting with n equals 1 to 8 of 4 times 2 to the n minus 1. We already know the sum's 1020, but the calculator will tell it to you just using the summation symbol there, 1020. So if you have this feature on the calculator, you may not have to use this formula right here, a sub 1 over 1 minus r, 1 minus r to the n. Anywho, if it's a finite, if it has a beginning and an end, yep. And that brings us to the next. This is still part of 7.1. There's a big old giant lesson. Infinite geometric series. Let's finish this up real quick. I'll give you guys a break and go run and grab a drink or something. But let's just finish this up. Infinite, or otherwise known as infinite. Actually, when you say it in this context, the E is no longer silent. Infinite. It's an infinite geometric series. No, it's infinite geometric series. So, yeah, this is, I need you guys to really turn your brains on here for a second. How many numbers are there in a sequence? There's an infinite number of numbers in a sequence. So what this is saying is you take an infinite number of numbers and try to add it all up. Does that sound strange to anybody? What do you think is going to happen if you add an infinite number of numbers together? What's the sum going to be? An infinite number. What about if all the numbers are negative? It'd be a negative infinite number, right? And that seems to make sense. It's actually not quite like that, though. Kind of weird. Write these two series down, or these two sequences, rather. 2, 4, 8, 16, 32. Kind of split your paper half. Draw a line down the middle of it and write these two sequences down, because I want to compare the two. And then on the right side, you've got 1/2, 1/4, 1/8. I have to go pretend to be a principal today. I've been doing this for a couple months over at the elementary school. I never told you about this?
No.
I'm a principal with training wheels. I'm a training principal.
Wait, Harvest Elementary School is retiring. You should go be principal at Harvest.
No. I'm in school right now to become a principal. That's what I've been doing the last couple of years. So part of my schooling is called the internship, so I have to intern at different schools. Right now I'm at Sage Hills.
Yeah, you should be a principal at elementary school. It's like, those principals are cool.
He's pretty
Here you
cool.
just can't interact.
Do you have a lot of homework?
There's a fair amount of homework. I have a 10-page research paper due tomorrow. I'm on page 0. I just don't have time. I work every night at UVU.
And you say, like, we are lazy.
I just don't have
You should
time.
be your own words.
I'm gonna 10 pages. That's no big deal.
What are the typing, like, requirements for fonts and stuff?
Just normal 12 point.
Hey, did you know that if you put the periods at like if you hold them, it like doubles it, and you can make double.
What?
I also have this list if you want to send it to you. It's gonna make it look bigger, but it's not.
Oh, I've been in school long enough. I know all the tricks.
There's like terms that you can use for everything. I have a list.
Anywho, tell me yes or no, you guys. This sequence right here, geometric. How do we know that? So this is geometric. Okay, what about this one? This is also geometric? What are we multiplying by? Okay, good. Now, as I go from left to right in this sequence, the terms are getting bigger. Much, much bigger, right? What's happening on this, though? They're getting smaller, and they're getting... It doesn't seem like they're getting that small, but then you get 1/32, and then you get 1/64, and then you get 1 over 128. and then 1 over 256. Those are pretty small numbers, aren't they? So just for right now, I want to focus on the left side of this column. If we just started adding parts of the sequence, like 2 plus 4, or 2 plus 4 plus 8. Matter of fact, you don't even really need to write this down, just so we can save time. Just watch this. 2 plus 4 plus 8 is 14. 2 plus 4 plus 8 plus 16 is 30. 2 plus 4 plus 8 plus 16 plus 32 is 62. The point I'm trying to make is, as I continue to add more numbers onto this sequence, what happens to the total? It gets bigger at a faster rate, right? So the sum is increasing. So if I added an infinite number of these numbers up in this sequence, what do you think the sum would be? If I took all the terms of the sequence and added it up. It would just keep getting bigger and bigger and bigger, right? This is what's called a divergent series. You probably ought to write that down at least. This series diverges on the left because as you continue to add more numbers, the sum just gets bigger and bigger and bigger without stopping. The sum grows and grows and grows. That's called a divergent series. That's a word you will have to know for your homework and for the test. This infinite series continues to grow without stopping. That's known as a divergent series. Okay. Now this one over here, 1/4 plus 1, or 1/2 plus 1/4. That's just 0.75. So write 0.75 right here for 1/2 plus 1/4. Now 1/2 plus 1/4 plus 1/8. Let's see. Might as well start over. There we go. So if I add 1/2 plus 1/4 plus 1/8, you get 0.875. So if I added another number, did the total get bigger or smaller?
It got bigger, right? 0.75 is smaller than 0.85, so the total got bigger. What do you think is going to happen if I add another number?
It's going to get bigger, but is it growing at the same rate that this is growing over here? So check out what the sum is here. If I add 4 terms rather than 3 terms, I get 0.9375. So it got bigger, right? Now just this next part you don't have to write down, but you really need to try to listen and understand this, because quite often this goes way over students' heads. But you really need to try to understand this. This is part of what you're supposed to know for the test. Rather than going to a 5th term and a 6th term, let me skip to the 10th term. If I wanted to add 10 terms of this sequence together, it went from 0.75 to 0.875 to 0.9375. So if I added 10 terms, just a guess, what do you think the sum is? If I added 10 terms of this sequence. Come on, guess. Little over 1? 2? Those are all good guesses. Any other guesses? Look at how it's increasing. 0.75, 0.875, 0.9375. So if I add 10 terms of this sequence, it's 0.9990. So it's a little less than 1. What if I add 20 terms? What if I add 20 terms, you guys? It's 0.999999. Has it become 1 yet? What if I add 40 terms here? What do you think that's going to be? You think it's going to be less than 1, greater than 1?
I'm not guessing.
Well, now this is a limitation of the calculator. Really what it is 0.99999. It's probably about 39s after that, 0.9999999. The point I'm trying to make is, if I increase the number on top, the number of terms I'm adding, doesn't that just add more 9s onto this? Okay? So put the phones down for a second so you can concentrate. I know you can do it. You can last more than 5 seconds without looking at that stupid phone. What if I added an infinite number of these terms together? How many 9s would I have after the decimal point? An infinite number of 9s? So here's my question. What is the infinite sum of this sequence right here? 0.9. Not just 0.9, it's 0.9 with an infinite number of 9s, right? 0.9 is different than 0.999 repeating. You guys following? So we can actually add all of these numbers up, even an infinite number of numbers. This sequence is different than, or this series is different than this series. And here's another thing to think about. The series on the left, if I go out to the 100th term on this series, is that a really big number or a really small number? Giant number, right? If you add a giant number onto the sum, isn't that just going to increase the sum a lot? What about the one on the right? What if you go out to the 100th term? What kind of number is that at the 100th term? You didn't even last more than like 30 seconds, Maddie. How about you put it in your bag?
I already have this listed. So
Oh, well, still doesn't mean that you should be on your phone. There you go. What about the 100th term of this sequence over here? What kind of number? Big or small?
Small.
How small? What about the 1,000,000th term of this sequence right here? It's really, really small. Pretty much what number is it? The sum is 0.9, but what about the 1,000,000th term of this sequence? Isn't it pretty much 0? So if you go out far enough in this sequence, essentially you're just adding 0 over and over and over again. So after a while, the sum is just essentially going to stop growing. You following? This is called a convergent series. This series doesn't continue to grow without bound, because after a while you're just adding such small numbers that they're almost 0. This is a convergent series. So just so you can keep this straight, you guys, there's 2 types of infinite geometric series. There's divergent series and convergent series. What's the difference? Tell me. Well, that's what divergent converge means, just as words. But what is a divergent series compared to a convergent series? Come on. Which one has no sum? Why? Why do these numbers keep increasing, and why do these numbers keep decreasing? Did you guys hear that? Why are these numbers continuing to get bigger, but these numbers are getting smaller? What's the difference between these 2 series? But why are these whole numbers and why are these fractions? They're both multiplying, but what are they multiplying by? What are we multiplying by over here? 2. What are we multiplying by over here? You guys think that's a coincidence? If the common ratio is 2, it diverges. If the common ratio is 1/2, it converges. Okay? That's not a coincidence. You need to write this explanation down here. An infinite geometric series converges if the common ratio is between 0 and 1. An infinite geometric series converges if the common ratio is between 0 and 1. Like the one on the right. The common ratio is 1/2. That's certainly between 0 and 1. That's why this series converges. Yeah. The series diverges. It has no infinite sum if the common ratio is greater than 1. Like this one on the left. The common ratio was 2. So it diverges. Let me go back up to this for a second. What did we say the infinite sum of this sequence was right here, or this series? If you kept adding more and more terms, doesn't that just make more 9s out here? So if you added all the terms up, what did we say the sum was? Well, the 1,000,000th term was essentially 0, but as you kept adding more terms, what happens to this sum over here? So it became 0.99999 repeating. You remember this like from 10 seconds ago? You guys out there?
Yes.
Okay. It's like the lights are on, but nobody's home. I want you to write this next part down. The sum isn't actually 0.999999 repeating. There's a better way of writing that. Yes. Not yet. As soon as we're done with this.
Yeah. I thought you just wrote 0.99 and put a line over it.
Yeah. So I want you to write this, but that's not the actual answer to that question, what's the infinite sum of that series? It isn't actually 0.99 repeating. I mean, it is, but it isn't. You'll see what I mean here in a second. Let's call that x. 0.99 repeating. It's equal to x. Now, take both sides and multiply it by 10. What's x times 10? Alright. So you guys are awake out there. Here's a little bit of a harder question. What's 10 multiplied by 0.999999? 9.99. Very good. Nice. A lot of students don't know the answer to that question. So I'm glad that some of you do. If you multiply a number by 10, it just moves the decimal, as you've been taught since elementary school. Anywho, I'm going to take the original numbers I had, 0.99 repeating, and an x. Write it right underneath that. Draw a line underneath both of them, and subtract the two. What's 10x minus 1x? Okay, good. 9.99 repeating, subtract 0.99 repeating is 9. Good. So what does x equal?
1.
And if x is equal to 1, what does 0.999 repeating equal? Okay. 0.999 repeating is equal to 1. Does that seem weird to anybody?
Yeah. How's that possible?
It's more of a calculus topic, but along those same lines, what would 1.9999999 be? Or 4.9999999? You see what I'm saying?
Well, that's like saying. That's like saying.
It's not that we're rounding, because what does 0.999 repeating mean? There's an infinite number of 9s. So 0.99999 is getting closer and closer and closer and closer to what number? How close does it get to 1? It gets infinitely close to the number 1 because there's an infinite number of 9s, right? At that point, when it's become infinitely close to that number, it essentially becomes that number. This is, I mean, that's a very unmathy definition. You learn a lot more about this in a calculus class, but for right now, we don't call the sum 0.9999 repeating. We call it 1. The sum of all of these numbers right here added up, 1/2 plus 1/4 plus 1/8, all the way out to infinity. What's the sum equal to? It's not 0.999 repeating. It's equal to 1. Okay. Now, all you have to learn is the formula. You don't have to think theoretically about what all of these sums are going to be. There is a formula for the sum of an infinite geometric series. If it converges, here's the formula. This is the formula for an infinite geometric series. A sub 1, that's the first term. Glad to hear it. I don't know. I was probably born with it. Kearns High School. It's a little bit older. Ice cream? Nope. There's no ice cream made at Kearns High School. There's a Baskin Robbins there. Is that what? Not that I know of. You lost me there, Brady. We're almost done with this. Okay. So, take a look at this problem here. What does this symbol mean? It means we're going to be adding a certain number of terms. But what if I told you we're going to start at 1 and end at infinity? How many terms are we adding? So that's an infinite geometric series, right?
Yes.
So can we use this formula?
No. Yes.
Only if it converges. So before you start writing, just tell me yes or no. Could I use the formula for this series right here? Why not?
Does this series converge or diverge? You guys wrote the definition down? How do we know it diverges? The common ratio is greater than 1, so it wouldn't even be worth it to try to use that formula because the series doesn't converge anyway.
You got that? What about this one? Can we use the formula on that problem? Because what's the common ratio? And that's between 0 and 1, so this kind of series converges. So you write this one down because we can actually figure this one out. So if you started with 3,
And then added 3/2, and then 3/4, and then 3/8, and then 3/16.
that's what that sequence means. All the way out to infinity, what would it equal? Well, you don't have to go out to the infinite term. You just have to use this formula. What's the first term of the series? 3. And then it's 1 minus the common ratio. The common ratio is? So it would be 1 minus 1/2. Okay. Well, 1 minus 1/2 is just 1/2. So this is 3 divided by 1/2. And 3 divided by 1/2 is 6. So what this is saying is if you wrote down every single term of this series all the way out to infinity and added it all up, what would it equal?
According to this formula, it equals 6, but it really technically equals 5.999999999 repeating. Yeah. So this one equals about 5.99999 repeating.
Which essentially is the number 6. Okay. Yep, answers are 6. Wait. I just drew a perfect, what was that, a pentagon? Freehand. I'm in the zone today. All right, that's it for this one.